Hello class and welcome to week 6. This week we will be learning about non-parametric machine learning algorithms, and we will focus on one frequently used algorithm, the decision tree. Algorithms that do not make strong assumptions about the form of the mapping function are called non-parametric machine learning algorithms. By not making assumptions, they are free to learn any functional form from the training data. Non-parametric methods are often more flexible, achieve better accuracy, but require a lot more data and training time. Some examples of non-parametric algorithms are support vector machines, neural networks, and decision trees. In the past decade, decision trees have become very popular, and they're being used much more frequently than in the past. Anytime that you turn on your phone and use a face or a thumbprint recognition feature to unlock the home screen, you're using a decision tree, or to be more precise, a random forest. Furthermore, anytime that you turn on an Xbox Connect and you fire up a Just Dance game, that Xbox will be using a decision tree to determine if it's you, a spouse, a different family member, or a friend who's logging in to play. It's helping the Kinect decide through detecting an arm, a shoulder, a leg, or a face who's turned on the game. Also, by being able to detect faces, we're, for example, able to distinguish between pedestrians and buildings, which will help us lead to a self-driving car. So how do we represent a decision tree? The representation of the decision tree model is a binary tree. This is your binary tree from algorithms and data structures. Each node represents a single input variable, or x, and a split point on that variable, assuming that the variable is numeric. The leaf nodes of the tree contain an output variable of y, which is used to make a prediction. Predictions are made by walking the splits of the tree until arriving at a leaf node and outputting the class value at that leaf node. The algorithm, the decision tree learner, builds a decision tree from the top down as follows. The input to the algorithm is a set of input features, a target feature, and a set of examples. The learner first tests if some stopping criterion is true. If the stopping criterion is true, it returns a point estimate for y, which is either a value for y or a probability distribution over the values for y. If the stopping criteria is not true, the learner selects a feature, xi, to split on, and for each value v of this feature, it recursively builds a subtree for those examples with xi equal v. The return tree is represented here in terms of triples representing an if, then, else structure. There are many advantages of using decision trees, such as they're simple to understand and to interpret, they require little data preparation, they're able to handle both numerical and categorical data, and they're able to handle multi-output problems. The cons of using a decision tree include that decision tree learners can create over-complex trees that do not generalize the data well. This is called overfitting. And there are concepts that are simply too hard to learn because decision trees do not express them easily, such as XOR, parity, or multiplexer. Decision trees are best understood by analyzing an example. So let's look at a sample of 20 students with 3 different variables. First, gender, boy or girl. They're in a class, either 9th grade or 10th grade, and their height is either 5 foot or 6 foot. 15 students out of 20 play soccer in their free time. So our task is to create a model to predict what kind of student will play soccer during their free time. In order to solve such a task, we will group students based on highly significant input variables among all 3. So this is where the decision tree helps. It will group the students based on all values of 3 variables and identify the variable, which creates the best homogeneous set of students. By analyzing data, we can see that the variable gender is able to identify the best homogeneous sets compared to the other 2 variables. So how does the decision tree identify the variable and the split? Decision trees use multiple algorithms to decide to split a node in 2 or more subnodes. The creation of subnodes increases the homogeneity of resultant subnodes. So, in order to select a split, decision tree splits the nodes on all available variables and then selects the split which results in most homogeneous subnodes. The algorithm selection is also based on type of target variables. Here are the 4 most commonly used algorithms in a decision tree: the Gini index, the chi-square, information gain, and reduction in variance. For more information, please click on the links to your online textbook, Artificial Intelligence: Foundations of Computational Agents, and read through chapters 7 and 9. The link is here for you to click on in the lecture, or you may go to your week 6 reading and click on the link there. In addition, there is a video for you to view this week. Please look through it, or you may view it in the video lecture section of your Blackboard Week 6 course page. Have a great week.